Alright, welcome to Algebra 2, Module 1, Unit 3, Lesson 6A. We're going to bust this one up into two videos, one for the one night, one for the next. And we're going to deal with simplifying radicals today. So we're going to go back to 9th grade and take it a bunch of steps further. Alright, in the opening exercise right here, I would like you to go and take a look here. It says, which of these statements are true for all a and b is greater than 0, and come up with y in that. So I want you to take a look at choice 1, 2, and 3 and see which of these work. So I'm going to have you pause the video for a second and I'm going to come back and explain it. Alright, hopefully you said no problem with part A. If I number 1 here, because if I take a look at that, you can put any numbers you want in. So if you take something like that and you go and do it 2 times, let's say we use 3 and 4. So 2 times 3 plus 4 is equal to 2 times 3 plus 2 times 4. And of course, we already know what property it is, distributive. So if I do it this way, it's 2 times 7, so the left side is 14. And the right, you'll get 6 plus, that was 2 times 4 is 8. And that will also give you 14. So that one definitely works. No problem. If you do part 2, a plus b, and I take the same thing, I do 3 plus 4 over 2. Is that equal to 3 over 2 plus 4 over 2? And of course this would be 7 over 2, and since this side on the right here has common denominators, we can add them and we get 7 over 2 as well. So that will also work, no problem. So the big one comes down to number 3. Take a few here. Now I want something that comes out as a nice square root and stuff like that, because if I don't, I get the square root of 7. I could take it that way if you want. Square root of 3 plus 4. Is that equal to the square root of 3 plus the square root of 4? And the answer is going to turn out no. This is the square root of 7. And then the right side, you're going to have the square root of 3 plus 2. Okay? The two of them, if you actually do it on the calculator, will not come out to be the same. Another way of doing this would be, let's take something like square root of, let's say stuff like 9 plus 16. Okay? Does that equal the square root of 9 plus the square root of 16? Well, 9 plus 16 is the square root of 25, which turns out to be a nice answer called 5. Coincidence, not an irrational number. It's a nice rational. This side, the square root of 9, you guys know, is 3, and the square root of 16 is 4. When I do that, equals 7. So it does not work. So this does not hold up. Proven in both cases, does not work. So that's a no for that one. All right? We're going to take that into the thing. So you cannot add things that are not like here. You can't combine them under one radical. So if I see something like a square root of 3 plus square root of 4, I cannot put them under one radical like we did here. It will not come out the same, just so you know and keep that in mind for the future. So, with that being said, we've got an example here. Square root of 50 minus square root of 18 minus that. Well, go back to 9th grade here, and we can figure this out. Square root of 50, you got to bust it up. And there's a couple ways of busting it up. One is to take the biggest perfect squares. You got to remember your perfect squares, which are 1, 4, 9, 16, 25, 36, 49, and so on, okay? So, obviously, the way I taught some of you guys in that, well, what's the biggest number? Let's take, first of all, you got to take half of that, because you want 2 times as the smallest you can go, and 2 times 25, and that turns out to be the way to do it. So, this is really 25 times radical 2. Now, I'm not adding or subtracting here. Minus, that still gives me radical 50, because you're allowed to multiply radicals and put them back together, unlike what we just talked about, adding and subtracting, you can't. Then 18, I take half of 18, and guess what? 9 is half 18, and 9 is in my list also up here, isn't it? So, sorry, this is a minus, my bad, let's keep it that way. Square root of 9 times radical 2. And then finally, I got plus square root of 8. What's half of 8? Well, that one works out nice. This happens to be a coincidence, all three are divisible by 2. So that's the square root of 4 times the square root of 2. So obviously, if you're looking at this, this makes 50, this makes 18 when you multiply them back together here. Now you got to simplify them out a bit. So if I do that, I actually get the square root of 25. I can take that out of the house. It is a perfect square. That comes out. The 2 does not. minus square root of 9 is 3. That comes out, but the 2 does not. And finally, plus square root of 4 is 2. So that comes out, but the other 2 does not. If you will notice something here, they are all having radical 2's, and we are allowed to combine, just like fractions with like denominators, we can combine like radicals. So this turns out to be pretty easy because all I have to do is take 5 of those radical 2's. It's kind of like 5x minus 3x and then plus 2x. It's really the same thing. Our radicals are really like an x. So if I take 5 radical 2's minus 3 of them, that makes 2, plus 2 more, my grand total here is going to be 4 radical 2. And that's how you get your answer. If this was something like a radical 3, we cannot combine that one with the others. You can only combine like terms. So let's move on to another example. All right, so a fraction is going to make you panic. Of course they do. Well, guess what? One of the rules in fractions is if I get a square root of a fraction, it's the square root of the top over the square root of the bottom. You can separate them. Plus the square root of 9 in this case over the square root of 4. Minus the square root of 45, which I would start breaking up again. If you go back to that list, half of 45 is 22. My list goes 1, 4, 9, 16, 25, etc. So halfway, 22 is going to fall in here. So does 16 go into 45 is the first one I would check. No. Does 9? Yes. So I would use 9 times 5. Once again, this is one of the methods. I'll talk about another one in the next step, maybe. One of the next ones. So what is the square root of 1 over here? Come back to this one here. Square root of 1 is 1. I can take it out of the radical because it's a perfect square. Square root of 4 is a perfect square called 2. Plus square root of 9 is 3. Square root of 4 is a perfect square called 2. Minus, then I know that square root of 9 is 3, radical 5. Well, combine these two together. These are fractions, basic stuff going back to 5th grade. 3 halves plus that is 4 halves. So I get 4 halves minus 3 radical 5. And of course, I can clean up. What is 4 divided by 5? It is equal to a 2 minus 3 radical 5. Now, if that was 3x, can I take 3x away from 2? Heck no. So let's treat it the same darn way as we did with polynomials. That's 2 minus 3 radical 5. End of story. Okay? Now, in another example right here, we got distributive. We know how to distribute. We can multiply. Adding, subtracting, you can only combine like terms. Multiplying, whole different ballgame. Nice and easy. What's square root of 2 times square root of 3? Guess what? It's the square root of 2 times 3, which is 6. You can put them together. And then I got a minus sign, and 2 times radical 2 is the square root of 4. Clean this up. Now, is the square root of 6? Half of that's 3. There is nothing less than 3 in the list other than 1, and pulling out 1 isn't going to do me any good, right? So, another way to look at this is, hey, this is really square root of 3 times 2 for the 6, isn't it? Minus, this one is the square root of 2 times 2. We already know square root of 4 is a perfect number. This is another way of looking at it, has no buddies. You need buddies to come out of the house, so you need a pair. We're doing a square root, so it's the opposite of squaring, so you need 2 of the same thing. They do not have anything in common. I cannot break them down anymore, so all I do is put them back together. So that's square root of 6, can't do anything with it. We already knew square root of 4 was 2, but just to show you this way, there's your pair of buddies. If you have a pair of buddies, they come out of the house, get them out. And the house is gone because there's nothing left in it. So it's minus just 2, which we knew square root of 4 is 2. Can I combine these two? Heck no, I can't take x minus 2 and combine them into something. That is your simplified rational expression. Moving on. All right, as we said, square root of 3 over 8, it can be written as square root of 3 over the square root of 8. Okay? Can't do anything with the square root of 3. It is just 3 times 1. We're not going to bust that up at all. However, 8, I can bust up in several ways. Once again, I can do square root of 4, which is the perfect square, 4 times 2, and get there quickly. Maybe you guys want to bust it up as the 2 times 4, and then you can bust the 4 up into 2 and 2. So you could do it all the way into prime numbers. See how I got a pair of buddies in there, right? So I actually get an answer square root of 3 over the 2 comes out, so I'll get 2 radical 2. Okay. Now, here's where we got to hold. We said this back earlier in the year. We would deal with this later. Well, now is the time to deal with it. One thing you're never allowed to do is to leave a radical in the denominator. Cannot be in the bottom. So the easiest way to deal with that is to multiply by that radical itself. on the top and the bottom. So since the bottom is the square root of 2, I put it there, and I multiply the top by square root of 2. So in essence, we are really multiplying by 1, aren't we? So if I take this one on a step further, what is the square root of 3 times 2? It's the square root of 6 in the top. And in the bottom, I've got a 2 radical 2 times a radical 2. Remember, there's a pair of buddies right there. So under the house, I got 2 sets of those 2s. So they come out. A 2 comes out times the 2 that's already out in front. So really, I get 2 times a 2 comes out. So I get square root of 6 over 4. Now, you may be tempted to try to take something out of the 4 with the 2. You can't. This is like square root of x here over 4. You would never do anything like that. So don't go trying to take a 2 out of both of these. This one has a radical over it. This has nothing. Your answer is left exactly this way. That's the final answer. And notice, no radical in the bottom. Okay, the denominator's been cleaned up. Okay, you will get most of your credit for this answer back here, but full credit, you got to be able to reduce to that and not keep. You got to. It's called rationalizing the denominator. All right, this one here. Now we change. What do you notice? This is a cubed root. A little different. So now, instead of looking for buddies, we're going to look for 3 things, or you have to know your perfect cubes. Well, cubed root of 5, I can't do anything with. But just like the square root, I can do a cubed root in the bottom for 32. Well, I can't break up 5, so guys, I'm not going to be able to touch that. I'm just leaving it alone. However, we can break up 32. And 32 is 2 times 16, so there's a 2. And I can break up 16 into 2 times 8. Then I can break up 8 into 2 times 4. Then 4 is 2 and 2. So I get 5 2's to make that up. Now, remember, there were pairs of buddies up here because of square root. Going back to this original one up here, that's really an unwritten 2. When we do square roots, we don't put a 2 inside this little area here, okay? But when we get bigger than that, we put 2's in, we put 3's in, 4's in, 4th roots, 5th roots, etc. So since there's 3, I need 3 buddies coming out. Set of 3 would have to come out. So if I take a we will get, let's take a look at this here. I actually get, in this case here, cubed root of 5 on top over that 2 comes out. There's 3 2's that come out as one single 2 out in front in the denominator. And then I have the cubed root of 2 times 2, which is 4. Now remember, 4 is not a perfect cube. That's a perfect square, so you cannot pull that out. It's not a set of 3 of anything here, okay? Okay, so that's where you normally leave it, and there is a way of busting this down. I do not want to tackle this at this point, so I will leave it here. I know we're not allowed the radical in the bottom. Dealing with a cube root even bigger is going to be a little more complicated, nothing major, but we're not going to deal with it at this point. So just hang in there. We'll get to that at another time. All right, last one here. I'm doing the cubed root of 16x to the 5th. So break it down. How do you break down 16? 2 times 8. 8 gets down to 2 times 4, and 4 is 2 and 2. So 4 2's make up 16, and then I get 5 x's out of this, okay? There's no fractions here involved. Once again, what do we need? Pull out triples. So I need to pull those out. And I need a set of 3 of the x's. I have at least them. Unfortunately, I don't have 3 more 2's. I don't have 3 more x's. So these guys are going to be left under the radical. So what comes out here? A 2. And you pulled out 1 x. And what is left underneath the cubed root sign? You still have a 2. And you have 2 x's. Or you can write it as x squared. And that is your answer. So I think you'll like that one a lot better. All right. One more slide to go. I got you. One more slide is a blank smile. So let's do a big smiley face here. You guys made it through that. You're welcome to watch those pieces again, and we will talk more in class. And that's the beginning of reviewing for radicals, as well as taking it steps further than we did back in Algebra 1. Okay? Have a good day. See you in class.